For question number 15, they're asking us how many right-handed and left-handed students there are in the school, given some particular information. It says there's 1,500 students total. It also says that there are 1,261 more right-handed students than there are left-handed students. And those situations are represented here. Everything they talked about deals with right-handed and left-handed students. So if I added them all up, the total number of students is 1,500. The other scenario says that there are 1,261 more right-hand students than left-hand students. So if I take the left-handed students that there are, and I added another 1,261, that should be the same as how many right-handed students there are. So those are our equations. I'll rewrite them here one more time. So if we added all the students together, right-handed plus left-handed, we should have 1,500. Also, the right-handed students are 1,261 more than the left-handed students. These two pieces of information together are what create the scenario that we're looking at here. It does not matter whether you use substitution or elimination. You'll get the same answer either way. I'm going to go ahead and say for this, since this one's already set up for substitution, that's what I'll use. So I'm going to plug all of this in for R. So over here, instead of R, I'm going to put 1,261 plus L equals 1,500. So I replaced R with this, and then I wrote plus L equals 1,500, the same rest of the equation. If I combine my like terms, it leaves me with 1,261 plus 2L equals 1,500. So I subtract the 1,261, and I end up with 2L equals, that would be 239. Is that right? Yeah. So I end up with 239. Divide that by 2, and we notice right away 239 is not an even number. If I divide by 2, it's not going to be a whole number. Normally you say, okay, no big deal, whatever, it's a fraction. Well, that's a problem here, because the question asks us how many right-handed students and how many left-handed students there are. We don't have half students. It's a little awkward. So if I divide this out, I do get a decimal, 119.5. So that doesn't mean that I have 119 left-handed students and then half of a left-handed student. That's a whole different investigation. Instead, I have to say, well, this is really just an estimate. It's an approximation. So you can say this is approximately 120. Now you would still use this number when you plug it into one of the original equations to find out how many right-handed students there are. So I'm going to take this 119.5. I'm going to plug it in here. So R is 1,261 plus 119.5, which means the number of right-handed students equals 1,380.5. And again, we have this 0.5. I guess one way you could look at it is if I have half of a left-handed person and half of a right-handed person, I guess I have one whole ambidextrous person. Either way of looking at it, though, you still need to round this off because they're asking about numbers of people. We don't consider half of a person in this scenario. So we would round this up and say it's 1,381. There is a problem with this. These are the final answers I would want you to put, because this is what rounding off should be. They both end with a 0.5, you round up. But these numbers no longer add up to 1,500. They now add up to 1,501. So some of you say, well, shouldn't I just have rounded one of these up and one of them down? Then it would make 1,500 exactly. That's true, but if you do that, the difference is no longer 1,261. So no matter which way you choose to round this off, something will still be incorrect. It's better to just round up for the estimation for the answer that they're looking for.